Crown Hall is a high modernist building built for and still functioning as an architecture school. It was designed by Mies van der Rohe and built in 1956, located on the campus of Illinois Institute of Technology, IIT. Crown Hall is a two-story building composed of steel, glass, and concrete. The building is 52,800 square feet and houses 650 occupants. Crown Hall is accessible from its north and south elevations with foot traffic circulating around all sides of the building. This axonometric drawing illustrates that Crown Hall has pedestrian walkways on both the east and west, which is an important attribute in my research. The building is organized into three main components: the primary structure, column-free ground floor, and the column-gridded basement. The ground floor of Crown Hall houses the main gallery spaces in the central portion of the floor plan. Symmetrically oriented are studio spaces, conference rooms, dean and admission offices, and flexible study spaces. The basement uses a symmetrical organization method as well. Note the traditional hallway structure informing the circulation compared to the ground floor. The basement houses studio spaces, lecture halls, restrooms, a cafe, and a library. There are four main entries into the basement, two centrally located stairways and two more stairways on the northern elevation. The north and south entries of the main floor also serve access to the basement below due to its interior stairs. My initial approach researching Crown Hall was to study its pre-COVID use and capacity. My baseline variables were a 6-hour school day and 650 occupants. Using Anylogic, simulated users are scripted to move throughout the building in multiple ways. Here, you can see a simulation of a school day pre-COVID, which serves as my baseline performance of Crown Hall. The ground floor performs well with few issues. The open floor plan aids in social distancing besides some congestion at the entryways and in the studio spaces. These entries see heavy volume due to their service of 2 floors. The basement sees much more conflict. The organization of this floor can be considered more traditional compared to the floor above. Many users come within close proximity of one another, especially when headed into the lecture halls. The lecture halls themselves are problematic due to dense seating arrangements and single-file circulation paths. These findings highlight the main problems I sought to solve, specifically congestion at the entrances and exits, the crowding in the basement hallways, and the organization of studios and classrooms. My first simulation focused on the ground floor entryways. Since the main entries serve both floors due to internal stairs, I decided to add more entries. The additional dispersed entries allowed for an even distribution of occupants. Here, you can compare the simulation with the 2 new entrances. Note that no hotspots appear in the updated plan on the right. My second simulation focused on the hallway in the basement. The single traditional hallway caused lots of crowding, so I added an additional corridor to allow users an alternate pathway. You can observe users moving throughout the new corridor, which reduces congestion elsewhere in the plan. My third simulation focused on studios. The original aisle structure created a lot of contact between students. Changing to a clustered desk organization reduced hotspots within the studio, and distributed circulation throughout the open floor plan more randomly, thus lowering the proximity of occupants elsewhere in the plan, as you can see here on the right. My final simulation focused on lecture halls. The lecture halls had a similar problem to the studios, making it almost impossible to socially distance. I added an extra aisle for more circulation, and I increased the space between each row of seats for further social distancing. Combining all of my interventions into a new analysis here on the right, Crown Hall has been significantly improved with regards to social distancing, as there are no more hotspots appearing. Both the ground floor and the basement now see minimal congestion, which can now suggest new design methodologies. These findings inform me of 4 critical principles to incorporate when designing for the future. Vertical connections create new opportunities for occupants to engage with the architecture. Distribution can be directed by focusing on access into the building. Increasing circulation routes, while having the benefit of greater social distancing, also create unique design opportunities. And finally, remote learning has showed us that we can rethink the ways in which we learn. Our studios and classrooms should reflect the adaptability and resiliency of modern education.